Today's lesson will focus on vertical and horizontal reflections. A reflection is a graph that's a mirror image about a line of reflection. The line of reflection is a line that the graph is reflected about. In other words, all the new points are equal distance from the line as their corresponding original points. A horizontal line of reflection affects only the y-coordinates. All the y-coordinates will be the opposite. A vertical line of reflection only affects the x-coordinates. In other words, all the x-coordinates will be the opposite. For linear functions, we can think about that as being f of x equals x. F of x equals x is going to be an increasing function. So in the example of f of x equals 2x, our slope is 2, and it's all increasing. If we put the negative out in front and our m becomes negative 2x, it is a decreasing function where our slope is negative 2. If we put the negative in with the x, it will also be a decreasing function where our slope is negative 2. In the case of proportional linear functions, the vertical and the horizontal translation results in the same line. If we think about exponential functions, b to the x is our parent function. H of x, we put in negative 1 as our a value, and it will reflect vertically over the x-axis or the line y equals 0. If we do it in the exponent instead, and we have b to the negative x, it will reflect horizontally over the y-axis or the line x equals 0. So in the example of f of x equals 2 to the x power, or h of x, we put a negative 1 for our a value out in front of the parent function. And for g of x, we put a negative 1 up in the exponent with the x. Let's take a look at the tables and how they differ. For our parent function, the table is exactly as we created in our last lesson. For the h of x, though, it affected only our y values, and we can see that all of our y values changed to negative. So on the graph, we have our parent function is increasing across the entire domain. Here we have our line of reflection of y equals 0. And you can see each of the points are equal distance from that line, but just the opposite sign. For our g of x equation, it only affected our x values. All of those became the opposite sign. We can see our line of reflection is x equals 0. And all the points are equal distance from that line. So, in summary, if the a value of an exponential function is negative, the function reflects vertically over the x-axis, and all the y-coordinates are the opposite sign. The line of reflection is y equals 0. If the negative is up in the exponent, such as in the g of x equation, the function reflects horizontally over the y-axis, and all the x-coordinates are the opposite sign, and the line of reflection was x equals 0. What else changed for a vertical reflection? It went from increasing to decreasing. Notice that the y-intercepts also changed from positive 1 to negative 1. And for here, for our range, all the y's are greater than 0, but for here, all the y's are less than 0. If it is a horizontal translation, we simply switch from increasing to decreasing across the entire domain.